Graph the system of inequalities, label the vertices, and determine whether the region is bounded or unbounded. Before we graph these inequalities, we might want to rewrite the corresponding simpler inequality. 30x plus 10y greater than or equal to 5 can be simplified to 3x plus 1y greater than or equal to 5. Graphing this simpler inequality will give us the same graph of the original given inequality. For the second inequality, we can reduce it to 1x plus 2y greater than or equal to 5. And the third one, it is 1x plus 6y greater than or equal to 9. And then x greater than or equal to 0, y greater than or equal to 0. So this is an equivalent system of inequalities. For the first three inequalities, we just simply divide by both sides by positive 10, and so it doesn't change the inequality sign. It is much simpler to graph 3x plus 1y greater than or equal to 5 than dealing with larger coefficients. There are 5 inequalities. We would graph each inequality separately, individually. For the first inequality, when x equals 0, y equals 5. And so the y-intercept is 5. This is a linear inequality. And when y equals 0, x is 5 over 3. 5 over 3 is almost 2, larger than 1. And so the y-intercept is somewhere here. And so again, when x equals 0, y equals 5. And when y equals 0, x is 5 over 3. And the reason why we only need to get 2 points because this is the linear inequalities. Observe that all of these inequality signs have the equal sign, so we would use the solid line instead of the dashed line. Once we have the 2 points, we can connect the 2 points using, again, the solid lines. It is difficult for me to draw one straight line here, so I have to break them into segments, but this is one solid lines. Then we would need to shade the corresponding region. This line separates the plane into 2 halves, one on the left hand side or below the line and one on the right hand side above the line. Picking any arbitrary point that is not on the line such as the origin where the x-coordinate is 0 and the y-coordinate is 0. We test to see if the origin is in the solution region. We see that 3 times 0 plus 1 times 0 is 0. 0 is not greater than 5. And so this point is not included in the solution region. This line separates the plane into 2 regions, one on the left or below, one on the right or above. Since the origin is not in the solution region, this region is not the solution. Therefore, we would need to shade the upper part. And so this is the solution region for the first inequality only. For the second inequality, when x equals 0, y equals 5 over 2, and when y equals 0, x equals 5. Again, we grab the equation, the linear equation, and then we would shade after. This is the linear inequality, so we would grab the corresponding linear equation, and that line would go through the 2 points. The y-intercept is x equals 0, y equals 5 over 2, and the x-intercept is 5, 0, which is here. And we would use the solid line. Again, this is one solid line, but I have to break it down to parts so that I can draw a straight or almost straight line here. It's supposed to be a straight line, so please use a ruler. And then we pick any point. Ignore the first graph. Just focus on the blue one only. This blue line separates the plane into two regions, one below the line and one above the line. To determine which region to shade, we pick the origin because the origin is not on the line. And then we test to see if the point 0, 0 is included in the solution region. 1 times 0 is 0, plus 2 times 0 is 0, and 0 is not greater than 5. So this point is not in the solution region, meaning this region is not the solution region. So therefore, we will shade everything above the line because, again, the region below it is not the solution. So far, this is the only part that we shaded twice. But that's not the solution yet. Not yet, because we still have 3 more inequality to grasp. For the next inequality, it is a linear inequality, and when x equals 0, y equals 9 over 6, or 9 over 6 is 3 over 2. And when y equals 0, x equals 9. And so we would plot the 2 points, x equals 9, y equals 0 is one of the point on the line. We're going to go a little bit further here because the point 9, 0 is way out here, not drawn to scale here. The y-intercept is x equals 0, y equals 9 over 6, or 1.5. So 1.5 is somewhere here. That is 9 over 6, or 3 over 2. We then draw the line that go through these 2 points. Again, please use a ruler. We then need to determine which region we need to shade above or below this line. If we plug in the point 0, 0, we see that 0 plus 6 times 0 is 0. 0 is not greater than 9. So we would need to shade the part that is above the line. Everything that is above the line. And it is the solution region for the third inequality. And lastly, x greater than or equal to 0, meaning everything on the right side of the vertical axis, and y greater than or equal to 0, meaning everything above the horizontal axis. The part that we shaded over and over and over is the solution region, and the part that we shade many times is this region up here. This region up here. Not the bounded region, because we shade it above this blue line. Every time we shade a region, we shade it above the lines, above the lines, above the lines, and so on. And in the first quadrant, this solution region is unbounded because it keeps going up indefinitely. And so again, this is an unbounded region. And to label the vertices, we see that the first vertex up here is when x equals 0, y equals 5. This is 9, 0. This is 5, 0. This is 5 over 3, 0. This is 0, 9 over 6, or 0, 1.5. And for any other vertices, we can find the intersection of the two corresponding lines. For example, this intersection is at x equal 1, y equal 2. This intersection is when x equals 1.235, y is 1.294. This intersection up here is when x equals 3, y equals 1.